At that time, what I'm going to do here is we told it everything we can about structure one. Now let's go to the tab because we can let this thing go ahead and calculate the drainage areas. So let's get the drainage area for CI1, which I think is half the road down here. None of this over here. This all falls this way. This comes this way. And so I think it's just going to be half the road and some stuff. So we have the option. If you want to hand draw them, go right ahead. If you want the program to use your surface model, this is where merge comes in. So I'm going to click and let it calc, and we'll see what we get for our drainage area going into CI1. Give it just a second here. It's all kinds of sinks and stuff. There you go. So that looks pretty good for me. Now, I don't know if I would buy that. It should be more of kind of a line like this, but I don't really care. It's going to be fine for what I'm doing. It don't matter. So uh, that's the drainage area coming off of my surface model. Okay. And it tells us the drainage area. It tells us the time to inlet, which is 9 minutes, but I'll overwrite it and say 5. Also, it's calculated our weighted C. If we click this box here, here you can see the different concrete, asphaltic. There are no roofs inclined in that area, so we're not getting it. And so there's where the watershed layers creates the ground covers that give us these coefficients and curve numbers. Okay, if you have a known flow, let's just say you've got offsite drainage coming in, you got 2 CFS or something like that, you could put it in right here. Okay, you could add 2 CFS in. Now, do you want it to be calculated as if it's going in through the inlet, which would take into account bypass? Or do we want to just add 2 CFS to a pipe run and not let it be part of our bypass, things like that? You can also use inflow hydrographs too if you have one for the offsite stuff. Now, your pavement long slope, cross slope, this is gutter spread. So what I'll do is I usually calc the first time, and it will give me the longitudinal slope and the cross slope. That pavement cross slope better be close to 2% because that's just normal crown, and that's what my template said. Now, also down here, you can specify whether this inlet is in a sag or on grade condition. Reason being, gutter spread is calculated differently in a sag or a low point. Okay, so you need to specify this one, he's on grade. And there's my pipes maining in. If you click on the outside the library, you can go to the out to the library where the mainings ends are and just select the one you want. So now we don't have a pipe yet, so I can't go look at the pipe. We don't have much on the hydraulic calc yet. So now what ends up happening is we've told it everything we can about curb inlet one. Now it becomes a rinse and repeat type of deal where you pick a point. I'm going to come over here. I'm just going to snap to the endpoint, and it tells me this is one of those prompt. I'm being prompted. It's going to connect the CI1. The link's going to be 10122. Is that fine? Sure is. And so now what happens, it's calculating that, it's recalculating the drainage area on the very first one because we'd maybe take an area from it. And so that's what it has to go back in and recalculate and do all that good stuff. So now what I got here is CI1, CI2. Now we're looking at CI2. What could change here? Not a whole lot of anything, to be quite honest with you. I'm not even going to touch an invert. I'm just going to let them be. And then I'm going to come and let's go to the drainage tab. We'll let the program calculate the drainage area for CI2. And when we get him, There it is. That's all it is. He's really kind of a junction because this whole road falls off this way. So he's really just to get me across the intersection. And where I'm located, water's not allowed to go across the intersection, so I have to. You guys may not, but CI2 is in. Now, what did we get new? Oh, we got a pipe. And if you look, here I can specify that very first pipe size. And then all the rest of the pipe sizes will be 15-inch. The pipe material, let's go RCP3. I think that says 3. It's circular. That's fine. Here's the inverts. I'm not going to mess with any of that stuff right now. I am just going to go and we'll look at the hydraulic calc and see what we got out of it if we get anything yet. Yeah, I don't see a whole lot, but let's keep going. So I'm going to go back to my structure tab. You don't have to. You can just click add, and I'm going to keep going down the system. Guys, I may run a little over today because it's hard to show a lot of this stuff. I'm just going to say yes. It's doing all the stuff behind the scenes for me. And there's CI3. Okay. Now I'm just going to come down here and I'm going to add in one. I'm just going to pick him right there. Pipe length, that's fine. I haven't even touched an invert. I could care less right now at this moment in time. Uh, it's because you'll see. Then I'm going to add this last guy in here real quick. Okay. So I'm just going to snap to the end. Yes. And so now we'll get our uh, catch basin one. Okay, catch basin one is a low point down here in the bottom. I rotated the cul-de-sac to force a low point down here to my detention pond. And now let's go ahead and throw in our flared in section. So I am going to snap to the end. Yes, this is fine, but this does not have an inlet. So we got some things to change. So what I do, I'd come in here. There's no inlet. There's no structure. Now there is kind of a structure here, and what I use are flared in sections. Now I'm estimating a 24-inch FES on the end of this. I don't know yet until I design these pipes. So now, if I go back upstream, let's just make sure I'm going upstream. I want to make sure I've got drainage areas for all this mumbo jumbo. Let it calculate on its own. Should come up and be this half of the road. Yeah, see, that's pretty good. Wrapping around catch basin 2, that's pretty cool. And so then we'll go downstream and you guys can see the drainage areas. You can see what it calculates as your runoff coefficient. Back in the day, I would use a lot of times I'd draw all the way up to the front of the building across and back like this. And it would seem like it was always like 0.55 to like 0.5 to 0.55. So you could always just come in here and type that in if you want to. And nobody says you got to do it the way I've showed you for the past hour. But now I'm just going to keep going because I want to show you guys how 5 minutes. Let's get the drainage area, and that'll adjust my time. So yeah, that's still a little something funky, but it'll do for the time being. And now let's go down. Now we're in here. Let's calculate our drainage area coming to that guy. This one may be a little big. And you'll see once we get a hold of it here. That's the drainage area from him, and he's half the pavement. So you can see I was kind of thinking I'm going to have a gutter spread issue. Might as well get ready to pop a box here and a box here. And, because you can see that drainage area is kind of big, 3 acres takes 27 minutes, but I'm going to cut it down to 5. And then you can also see that weighted C has a lot of area out here that's just grass and stuff. So that's how that is rolling. So we're going to leave it just like this for the time being. And now what I want to do is I'm going to show you guys the spreadsheet sewer editor. Okay. If we do pipe profile, we get a spreadsheet sewer editor. This shows the whole pipeline. You can look at just one segment at a time. Okay. But what I do is I like to look at the whole thing at one time. And this way I can start to see here's the inverts. I'm going upstream to downstream, that kind of stuff, little doodads like that in here. But we ain't designed nothing yet. So, oops, hold on just 1 second. Um, what we got here is well, of course, you can see down here we're bucking grade. That ain't gonna fly on my outfall. I should probably say like 0.55. Flatten it out, let it run. But now what you can see here is the EGL and the HGL. It's not surcharging, it's just backing up in the box. Is that going to be fine? Sure, that's fine. If that's what they'll let you, but if you don't want them to be under pressure, let's see what we can do. So what I'm going to do now is I'm going to come in here and I am going to go back to my settings and I am going to come under the design tab and let's do a little automation. Okay. Auto set the sewer pipe sizes. Let's auto set the invert elevations of the sewer network. We could add a step up to minimize our excavation if we wanted. We'll just leave it alone. Auto match pipes at junctions, minimize pipe size and design. Don't do automatic watershed because it takes too long. And so I just don't check it. Now I go back in here. I come back and here I just checked on a few boxes that I wanted. Now up here at the top, you can see I could tell the program to design my sanitary sewer. Now, you see why I wasn't worried about inverts. I could care less about inverts. I just pick, 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 tell it the type of inlet, the structure, the drainage areas, and start off with your first pipe size being 15-inch or whatever the minimum is, and everything else falls into place accordingly. But what I can do now is by going and checking those boxes, I could come up here and say, let's design. Now, this is when you get that moment of clarity, okay? Prompted. Are you sure you have chosen to overwrite the current design? This is extremely important. So this is why I want prompted. So I can say yes or no. So I'm going to say yes, and the program will go through and design this storm. I've got 3 errors. Okay. I've got velocity problems. Now, is this something I need to worry about? I don't know. You make the call. 2.5 feet per second, 2 feet per second. You see what I'm talking about? Then, of course, we got some gutter spread, which I'm pretty sure is in the cul-de-sac. And the little arrow points to the cul-de-sac and zoom in. You see, I got a gutter spray problem, but in the sag, which I knew. So, which is another reason maybe I need to add a box here. You see, and that way I can intercept a little bit of this before, and the drainage area for the low point would only become this right in here, right? So, I can, by adding other boxes in, I could split this drainage area in two if I added a box here to help us. Okay. So let me exit this. And now let's go look at this spreadsheet sewer editor and see what we got. All right, so you can see all my pipes to start with for 15-inch. We let it design, it ended up with an 18-inch pipe. Every single one of these. Now, let's go back in. Let me say, okay, here. Let's go back and edit. When you hover over these boxes, you'll get an edit. And then I'm going to come up here and I'm going to edit CI1. Okay, let's go ahead and add to CFS and we'll come through the inlet with it. And now we'll come back up here. Let's go look at our thing here. Looks like it didn't, well, it raised things up just a little bit here and there. Didn't know what that is, but we'll look at it. And so now I can come back up here and say design again. Oop, failed to read sewer file. Uh-oh. No. Okay. I'm trying to make sure. I think I got my fingers going too fast. Um, so now, yeah, there's no pipe there, so there's no harm, no foul, RCP3, everybody else. Now, if I come up here, I can design this thing 6 ways from Sunday. Now look, hmm, total gutter spread. So those velocities were not a problem after I designed it again, but still got my 13.5 feet spread in the sack. So I can exit. Let's go back and look. So now you can see, here we go, HGL, EGL, everything's inside the pipes. We're matching crowns. We went to a 24 inch. Maybe, just maybe, if I make that pipe size an 18 inch, I'm a little bit under pressure. It's backing up in the pipe a little bit, um, but it's not surcharging. So this is the kind of stuff that you get to have fun with. And it actually makes designing this stuff so super simple that, when you start putting in all these pipes and things start moving and acting the way you want to, then you're pretty happy. And now, let me tell you guys, this is not designed, but damn if it ain't pretty close. Okay, this looks pretty nice. The pipes are not deep, and I'm kind of happy with it for the time being. So you know what I do? I come in here, the out, let's just say it's 340, 340. Then we're going to come up and I'm going to, come on, there we go. Get that, 0. That hopefully, yeah, well, that one should have changed. I may not have said it, but you guys see the gist of what I'm doing here. I'm rounding numbers. That's all I'm doing. And so you see, this way you can give something to somebody that looks halfway decent, at least to the, point oh 0.05, something like that. I do it anyway. But now, if if you were to do something down here, uh, right now the program's forcing us to match crowns. If you want total control of these pipes, you hit none. Now it's in your hands. Okay, all these numbers up here can be modified, except the ones that are grayed out. They're just information. You can come down to your display settings here and decide the order and what you want to see in this spreadsheet. Okay. Uh, so you can do some adjustments. You can look at your hydrocalc, it'll recalc and do all that kind of stuff. So let me go ahead and say, okay, if we're happy, we're happy. If not, then we got something to do. So you could say, okay. And then really right now, you could, yeah, while it's doing its thing, you could analyze. Analyze the system does not change a single thing. It just shows you where you have a problem. Okay. And so that's how you fix it. And you go in, well, you could put maybe 2 inlets here. You could do something, or you could pop a box in right here and cut the drainage area for this into a tenth of what it is, and then break it into 2 pieces and go drainage area from here to here and from here all the way back over in here. So you've got those options. It's pretty simple in its concept. Don't overcomplicate it, because really I set this very first invert because I know I need at least 5.25 feet to the invert minimum. Okay, so I set that one. The rest I just pick, do the drainage areas, set that first pipe slope. to 15 inch and get the material, everything you can tell it about that very first pipe when you see it, and then everything will adopt the previous settings all the way down. Okay. So that's actually how you can kind of design storm drainage. I know an hour is so not enough time for me to teach a lot of this stuff and to teach it heavy hitting. But I have created movies that are on the Carlson website that you guys should use if you decide to edit these things. Because this thing is designed now. I just exit, save the changes, and go on about my business. So what I'm going to do, I'm not sure why it's failing to read my network file, quite honest. But we can start to now look at perhaps profiles. So if I went to my network, draw sewer network, I'm going to draw a profile. Okay. I'm going all the way from the downstream structure here, and I'm going to pick all the way up to the upstream structure here. Okay. Do I want to draw my tributary pipe crossings? Yes, those are ellipses of incoming pipes. Okay. In these catch basins. Okay. Do I want to see the hydraulic grade line? Yes, I do. I'll take it for the 10-year storm. And then, do we want to draw our existing in the design surface? Now, the design surface is not my merge, although I could use it. It's really my FG. So I'm just going to set it, be done with it, let it be. If you wanted to extend, you could extend it, 50, 100 feet, whatever, at the end and at the beginning, but I ain't too worried about that right now. So now it's going to come. Carlson wants to write a profile for us. Okay. It's called CI6 to CI1. It's naming it after the two structures I picked, CI1, CI6. So I'm going to save it. And so now it's reading the surface models. Okay. And so now what happens, it comes up here and it pops up this dialog box about, do I want to draw a grid with this? How do I want this stuff to look? I'm just going to load some settings right quick, and we'll do 2020 horizontal scale, 50 and 5. It could be 40 and 4. To that, some people do that. But if I come in here and I look at my sewer/pipe profile labels, you can see what it's going to look like when I do these settings and things in here. Now, if you guys watch this, this stuff is stuff that you can set up. If you don't already have it set up and you like mine, I'll send you mine. You can have mine to get started with. All you really have to do is go in and change the layers that you put stuff. Okay. So now what I'm going to do, just because for safety's sake of time, I'm going to go ahead and say, okay, here's my grid. If I wanted to use fixed tops and bottoms, I could, but this is what I'm going to do. And now I can check against other sewer networks and draw the crossings for them. Okay, let me go ahead and get the crossings for beta testing. If you hold down the shift key, you can select them all. If you hold down control, you can select in, individually multiples. So I'm just going to say continue. And now it's asking me, hey, Mark, come up here and pick a starting point for your grid. So now here we go. And now what you guys can see is there's the HGL in the pipe and the pipe profile labeled like I want it, all that kind of good stuff. Man, let me tell y'all something. You know what? One of the best things I've ever got them to put in this software for me was this network edit profile view. Okay. Here, now you have to pick the inside diameter. And as you can see, I've got hatching of concrete inside mine. So it can be a little tricky at times. But if I pick this downstream invert, what happens is I am given a rubber band. Okay, so I can move this invert up, down, whatever I feel like doing. Now, if I pick in the middle of the pipe, which I will, so if I pick in the middle of the pipe, I can hold the slope. Okay, so if you like the slope, you want to hold it, pick that. And then, of course, if I pick the upstream end, I can rubber band with him. You can move structures left or right, but not up or down. Okay. And there's other ways that you probably want to do it anyway. Now, let's look at this. I need 2/10 drop, even though I told it for some reason I don't have it, but let's go ahead and make it. So I'm going to come in here. And you know what's the cool part about this is that if let's just say I drew grid at 1/2 foot interval. If I come out here and I go perpendicular to a polyline, that is an even elevation. So I'm snapping to even elevations and designing in this profile view. Okay. But right now, what we need is to put a step up in of 2/10 right here. Okay. So let's type in ST and enter the step up. Oop, let's go 0.2. Let it be. And there we go. So there you see there's 2/10 drop from the invert in to the invert out. And so now, and everything gets updated. Everything is cool. Uh, and so now, if we're happy, we move on. Now, let me tell you why I like this too, because apparently I've got two, I don't know what I've got going on in here, to be quite honest with you, the way that I do these things a lot. But if you look at this, outside diameter. Okay, let's just say I needed to draw a polyline from a quadrant. You'll see this in that movie too. Uh, there, and then if I could say I just want to go straight up perpendicular 15. That's 18 inches. We got to think vertically exaggerated. Boom. There is that separation. Now, when they start getting closer, then you're going to know exactly because you know why? This is a profile directly on the sanitary sewer. It's not along a center line. It's not, this is its own. These become my masters. Okay. And I make all my changes here, but then I'll come down here and draw those pipes on a road vertical. So anytime I make changes, I change the master. And what happens is they automatically get changed in my vertical roadway profiles, which sit over here. And that way I don't change them here. I change them here in my masters. I have a master for all my storm drainage and all my sanitary sewer. So the reason being is that uh, when you draw profiles in this program, it would draw a profile from 6 to whatever this new number, probably catch basin 7, and then from 2 to 8. So you can have it draw masters from your most upstream ends. There's common pipes in here. So if I was to change one in this profile, it's going to change it in every one of these profiles. So that's why I like to keep my masters here, and I can edit this. Also, not only can you do the profile design, you can also come in here, go network, edit, plan view. So you select the sewer structure, okay? And now it's asking me what's my new position. Let's just type in new. How about near? That's funny. So I'm just going to put it near right there. And we are going to, oops, it's asking me, I'm being prompted again. Do you want to change that profile that we put right up above us, the master? Yes to all. Okay. Now what's happening is why it's loading the surface model and doing all that kind of mumbo jumbo, but it's also lengthened out and adjusted this. What it does is it will hold this slope and you just move it to where you need it to be. If you have to come in here and change something because you get a little too flat, something, then you can just change it. Guys, this right here is about the easiest way I've seen. Storm drainage sizing is easy to start with, but this really, really helps design. And what we see is the HGL, all the computations are redone, and we see it in this vertical profile. How can that be? Well, if we go to network and we come down to draw sewer network, when we say profile, okay? Now, the 100% of the automation in Carlson software for storm drain, for automation for redrawing your pipes is right here. You want to set it to this because this is what writes that PRO. That PRO keeps track of changes. And so those changes are saved in this profile file. And so when we edit a network, boom, it automatically looks here and says, you don't match. What do you want to do? How do you want to fix this? And things like that. You'll get warnings about it right there. Always save file and draw. Overwrite those old files. Like if I was to say, okay, right now, and it pops up here, you see, I can overwrite this and it says it's already exists. You want to replace it. Yeah, why not? I'm changing it. This is a profile that's in my design. Overwrite them every time and it'll be just fine. Do you want to replace it? Yep. And so now well, it's wanting to erase something. I don't know. Oh, it's wanting to draw that profile again. I'll say, yeah, that's fine. We can erase it. And then say, okay, and okay, and let's do him. Now, if you hit enter, it'll go right back to the location it was last time you put it in. The first time you put it in is the kind of the one that's set. And from then on, you just hit enter. So that way you don't end up moving your profiles around if you move some text around or something to that effect. Uh-oh. You see, look at that. Need 18 inches. Got something to do. So now, if, real quick, network, edit, profile view, give me that guy. Perpendicular to there. So I'm snapping to an even elevation. Boom, it goes up. Now the clearance doesn't change here. I wish it did, and it will soon enough. But again, hold on one sec. I got to get my mouse back. I lost it. There we go. Again, here, polyline. Zoom in. Oops. Polyline. Let's get snap quadrant. Boom. We can go 15. Still a little tight, guys. Yeah, what are you going to do? Raise this up 2/10? You could. It'll be fine. You could just come in here and say, grab it, and oops, you got to run that command first. That would help. Profile view, grab it. It's going to load it up in there. And what we could do is we could just say, there's the elevations of what we're looking at. The old elevation, where I'm at now. What if we just change this and just simply type it in as 360.5? Okay, and we set that invert on that even elevation. Now all of a sudden you're fine. Okay, you see how cool that is? That to me is super easy, and all the hydraulics get redone for you too. So